Hello and welcome to the Take Charge podcast. Jon Bornstein, the President of Amprius Labs, joins me to discuss the dynamic world of silicon, their recently expanded production facility in Fremont, their upcoming Gigafactory in Colorado, and how silicon will accelerate the future of battery technologies and electrification. Over the past 11 years, Jon has been on an amazing journey with Amprius, so it's a real pleasure to speak with him about the challenges endured and the landmarks achieved. Jon, thank you for taking charge. Hi, Jon. Welcome to the show.
Thanks for having me. Great to be here.
Great. To begin with, Jon, talk me through your role and the history of Amprius.
I'm the president of Amprius Lab. Amprius was founded in 2008, received its first funding in 2009, and then it was off to the races. It's based on a concept that came from Stanford University to use silicon in the form of a nanowire, a nanostructure, to overcome a fundamental limitation of silicon in a lithium-ion cell. And that limitation is that when you charge silicon with lithium, it swells. And if you don't do it right, after a few charge-discharge cycles, it will literally pulverize. The nanowire approach was a way to overcome that. After we got off, as I said, to the races, we were racing to find a solution that was manufacturable, and we did, and that set us on a course to be a commercial company that we are today, and that commercial adventure, if you will, began in around 2018 with our first commercial orders to Airbus. And now we have a big portfolio of companies, mostly in aerospace or aviation, which plays to our wheelhouse.
Could you also give us a brief background on Amprius and what sets it apart from other battery manufacturers, particularly expanding on your silicon technologies?
So what we've done is we found a way to use silicon at its maximum content, which means the SiMax product has only silicon on the anode. There's no other binder, which is typical of a roll-coated anode. There's no graphite, there's no carbon. There's nothing except silicon. And the structure is such that we maximize its performance for both power and energy. That's the so-called nanowire structure. And so that is highly differentiated from anyone else in the industry. Silicon is incorporated in various other ways, typically in a particle form, where it's in an alloy of silicon, typically an oxide, or it's a silicon particle embedded in carbon. We're not diluting the enabling capacity of silicon with any other material. It's just pure silicon.
Silicon's been around for a while. Why don't we see more or other 100% silicon anode batteries on the market yet?
Yeah, so it's for the reason I gave earlier, which is that silicon swells when it's charged with lithium. And that swelling is significant. It's several 100%, depending on exactly how much lithium goes into silicon. And after a few charge-discharge cycles of that swelling and contracting, it will crack and cease to enable energy storage. And so that's the limitation. That is how much silicon you can put in without breaking your battery, so to speak. And while we do see silicon more and more getting incorporated into lithium-ion cells, it's a tough problem technically to get a lot of it into the anode. So that continues to be an area of development. Many companies in this space are pursuing silicon dominant, as it's called, anodes. But we're the leader because we have the most dominant, which means only silicon in the anode.
And do you think silicon batteries will become more mainstream? I mean, there's obvious benefits versus graphite. Do you see them completely overtaking graphite in the near future?
Well, we certainly intend to be a mainstream purveyor of lithium-ion cells with our silicon batteries. So to the extent that we're able to expand our manufacturing footprint, which is a major thrust today, uh, the opportunity to gain a mainstream position will be ours to win, so to speak. So, yes, I do believe that given the direction that we're going and the plans that we have to enable that direction, we will become a mainstream supplier in particular, the mobility space.
We had Iron Blocks on the show a couple of months ago, again talking about silicon technologies. It's quite a not necessarily a crowded space when it comes to silicon, but there are more players coming into the field. What gives Amprius the competitive advantage?
For all the things that I've mentioned, are the numbers, of course, are the most important thing to compare or contrast one solution versus another. We're shipping the highest specific energy cell in the market today. We're shipping the highest power to energy cell in the market today. And this is why we're sort of highly sought after by uh, companies with applications that need that type of performance. So it's really the numbers. For example, we published quite some time ago now a 500 watt hour per kilogram cell that we will commercialize later this year. We've been shipping in volume a 450 watt hour per kilogram cell, and that's to multiple customers in multiple SKUs. And to contrast that so that you get a sense of how that sort of compares with conventional. You know, an iPhone today has about 280, maybe 300 at best watt hours per kilogram. So if we're shipping 450, that's a significant difference. In the battery space, that kind of difference is monumental. It's step function. And so those numbers that we're uh, providing the market in terms of our performance are what set us apart.
You've obviously been with the company, John, for I think 11 years. So, what are
Yes.
some of the challenges that you've overcome with Amprius? Specifically talking about scaling the team, the pilot line, manufacturing processes, things like this.
Well, like all startups, growth is not easy because you're very selective with people. And also, you've got to make sure that you stay focused. The good news is that in terms of the technology approach, we're only changing one thing, that is the anode. The rest of the battery is fully derivative of standard materials and manufacturing methods. We're sort of an anode replacement solution. So that means that the bill of materials, the cathode, and all the rest of the components that go into a typical lithium ion cell are available on the market, and we're taking advantage of the best of those materials. And the manufacturing methods, the equipment, that's mature industry today. We're able to leverage that. And so the part that we bring, which is different and which is the differentiating feature, is the anode. And that's made differently than a typical electrode. It's not a roll coated material using a slurry. It's made using vacuum deposition. And so the focus for us is to leverage existing platforms that have already proven themselves in mass production, in our case for solar cells, and convert it or adapt it to the application for silicon anode. And that adaptation is the focus that we've undertaken, and the scaling of that on a platform, as I said, that's already proven, is what we're actually doing, and that's how that's our solution for mass production.
And what applications are you focused on today, and how do you see that changing in the future? Maybe as well changing your focus on different applications.
As I said, primarily the markets we're addressing are markets that really take full advantage of and frankly would not otherwise be viable without our solution. And that is typically in aerospace, and military is a key component of that. And what are we solving? We're solving problems of getting off the ground, which takes a lot of power, and then you want to have enough energy to then cruise to support a real mission, and then you got to have power again to land. So that sort of power, energy, power cycle is the key for these high performance applications. And these are typically drones. And so that's a huge market for us. And we're addressing many sectors within that market, from sort of nano drones to drones that are the size of a 737 in terms of wingspan. And that is what we're frankly dominating in today, because we're able to provide unprecedented performance. As we move forward and as these markets mature, we're a solution for the eVTOL, the electric vertical takeoff and landing applications, or flying cars. Urban air mobility is another term. Again, these are very different from land-based vehicles, where acceleration certainly is important, but it's not the sort of acceleration where you're fighting gravity. And you've got a payload, and of course, the bigger the payload, the more commercially interesting the product is. And so again, that's where we have a solution. We can enable high power without giving up energy, so that you can then go into the cruise phase of that sort of mission, which is to deliver passengers somewhere beyond a short radius. So it's aerospace today in the drone market, and in the future, it's passenger-based drones or passenger-based aircraft. And then eventually, as we get to the bigger scaling on the tens or 50 gigawatt hour type manufacturing capacity, we'll address electric vehicles.
You made some really interesting points there about eVTOL. There's clear benefits when it comes to EV, longer range, faster charge. Similar situation for any kind of consumer electronics or military. But I suppose with eVTOL and aviation, it's silicon technologies that makes it possible in the first place. I guess if it wasn't discovered and we're still focusing on graphite, eVTOL wouldn't even be a concept.
Yeah, that's probably quite right. You hit on the key points there. If you're a service where you're delivering passengers from point A to point B, you don't want to be on the ground very long. And you want to be able to have a radius to serve a fairly important geography or geographical span. And you've got to be big enough to make it interesting, so you've got enough passengers with whatever they're carrying to make a business out of it. But a key point is how long you're on the ground. And that's where extreme fast charge comes in, because your turnaround time, as we all know, as passengers on whatever we're embarking on, is really important. You don't want to wait. And also, the more back and forth or flights that you can take, the more money you make. So extreme fast charge, power, and energy, and that's what silicon enables, and our silicon design in particular, are game changing for the emergence of this market, which we see happening as we speak with companies that have become quite well known and will expand into real commercial products in the next several years, certainly in the second half of this decade.
I was interested when reading about your recent expansion in December. I saw the announcement. I think you expanded the facility or your capacity by 10 times in Fremont. So what's that going to allow Amprius to accomplish in the coming months and years?
It's very simple. It allows us to serve our customers with more product and expand our customer base. We've been capacity limited, not demand limited. That's the good news. But you can't stay capacity limited if you want to keep your customers interested and if you want to grow your customer base. So by expanding locally, we could do that fairly quickly, and we've completed that now. We can address markets more readily, and we can address more customers, and that's exactly what we're doing, and that also allows us to showcase our product more readily as well, because the more customers you have and the more markets you're addressing, the more interest there becomes, and it's a virtuous effect.
And let's get into the upcoming Gigafactory in Brighton, Colorado. First of all, why did you decide to build a facility in the US? And yeah, tell me a bit more about where you see those plans for the Gigafactory being in the next year or so.
So the U.S. is a critical manufacturing location, in particular for the military. And that's a key market that we are keen on expanding into and making sure that we stay connected to. They drive performance, and they are also very enabling for the proof points for these most advanced batteries. So you got to manufacture in the U.S. if you want to have a military presence. That's number one. Number two, you have better control in the U.S. if you're a U.S. company. And you've got to be able to not only design, but you've got to be able to develop and manufacture if you're going to continue to focus on the development of the technology. If you hollow out the sort of infrastructure of manufacturing and separate it literally from the development or design, you really can't make the sort of progress you need, or really own the solution for that is inherent in the manufacturing. And so manufacturing is hand in hand with being able to continue to drive performance improvements. And so you've got to have your own factory is the short answer, and you got to have it in the U.S. for the reasons I've already mentioned.
It's something that so many companies are aspiring to do, particularly in the US. So few actually achieve it. Just to run through some facts and figures on the upcoming Gigafactory in Brighton, I think the potential is 5 gigawatt hours, 775,000 square feet facility, the largest battery factory in Colorado, cell production expected in 2025, and it will create around 330 jobs in the first phase. Having been with the business for such a long time, John, surely it makes you proud to have kind of got the business into this position, which so many companies are trying but not succeeding.
Sure are. I mean, we are very proud of that, and we are very happy with where we have ended up with regard to the location. We're repurposing an existing facility, which is a little bit easier or lighter lift compared to a greenfield, as they're called, approach. And we're also in a good location relative to supply of critical components and materials. And we've been well received by the municipality and the state. So put it all together, you have a great solution in that location. And on top of all of that, there's a supply of labor. There are multiple universities, colleges, et cetera, and there's a pretty healthy workforce, so to speak. And so labor, of course, and talent acquisition is a very important consideration. And so this location, this Colorado, just outside Denver and Brighton, really has all of those attributes. And so it came together quite well for us.
Well, good luck for the next chapter in what will be a huge landmark, and there's been many landmarks at Amprius Technologies in recent years. And just to rewind a little bit, another big another big event was the new battery line. Is it SiCore, in addition to the
Yes,
SiMax line?
yes. So SiCore is another approach to silicon. As I mentioned earlier, it's called silicon dominant. This was developed by Amprius, it turns out, um, and we spun off that 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 entity, and it became a company called Berzelius. We have a partnership with our former affiliate where they're supplying the material, the SiCore material, and presently we're manufacturing lithium-ion cells that incorporate that in a with a contract manufacturer. This is as I said, silicon dominant, and it provides unprecedented performance as well, probably better than anything else out there with regard to a silicon composite approach. Uh, and so it allows us to have multiple product lines that span a spectrum of performance attributes, but all tilted toward high performance.
Great. And just before we finish off, and I get your outlook on how the battery will be looking in 10 years' time, any lessons that you'd like to um, provide to our listeners? So, over your journey in your career so far, what are the biggest lessons that you'd like to pass on?
Well, focus is probably the mantra that anybody who wants to get into something that's hard and that is unprecedented in terms of a technical approach has to have. So if you don't stay focused, if you get distracted, then you're not going to be able to make the progress. You're not going to be able to find the successes. The other thing is the team. You got to get the right people, and you've got to create the culture and environment where people are able to work at their maximum. And that has a positive feedback effect. And I think that's what we've done here. We've stayed focused, and we've got a great team. All the principals uh, are long veterans. I'm here 11 years, but I'm not here as long as our CTO, for example, who's been here since the founding, our chief scientist, among others. So we've been dedicated, and that dedication, of course, ripples through the rest of the team. And because we've been very, very careful on who we hire, we make sure that there's a very strong technical background, but also that they're a cultural fit. So you got to put those two together, focus and the team.
Great. And then the battery world, particularly in the US, is moving at such a pace. Where do you think, or how do you think the battery world will look in 10 years' time from now?
That's a tough question. 10 years is a horizon that's really tough to predict. I mean, 5 years is tough. But I think that what we're seeing as we speak, and I don't think that we're going to turn around or change the direction that we're on, it's probably only going to increase, is the reshoring, if you will, the onshoring of more manufacturing, not only at the assembly level, but also at the material level. We talk about lithium-ion cells, there's the raw materials of the anode, the cathode, et cetera, the electrolytes. So the manufacturing infrastructure for these advanced materials, where we can leverage our national labs, get the commercialization from those labs into the private sector, and build factories that are based on those innovations. I think that's the direction we'll continue to go. And I think only that there'll be, and I hope that we'll see this renaissance continue, and an expansion of the factory uh, that provide these solutions in the future.
As you say, it's an impossible question to answer, which is why I ask it. We don't know how the battery world is going to look in 6 months' time, never mind 10 years. So, no, thank you for that, John. It's been a real pleasure speaking with you. I know you've been on such a journey with the business over the past 11 years. Huge landmarks in recent times with the IPO. You have the expanded lab, the new technologies, the new products, and the upcoming factory. So, great to speak with you. Good luck for the upcoming challenges and the next 11 years, hopefully. And yeah, John, thank you again for coming on. It's been a real pleasure.
Thank you, Jamie. It's been a pleasure as well.